Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and the concepts of electronics. So I hope that the discussion which we will be doing today in this session will be getting clear to all of you guys. But in case anywhere if you will be having any doubt, we can surely talk about it. And one more thing, I'm going to show you some important slides here right now, and then we will be continuing the discussion too. Okay, so what I'm going to do initially, I'm going to share these important slides, like the first one, which is going to be regarding the offer which is going on Academy. Okay, and you can use and apply the code that is Anjali A Live to grab this offer. So as per this offer, what are the discounts you will get and how it will be helping you to even take your preparation to the next level, everything I'll be discussing here in this session. One more thing, guys, that like the offer is just valid till 14th April. So even if in case there is any of your friend like who was even waiting to take the subscription or wants to take the subscription, you can share this information with them too. You can let them know about the referral code as well, which is Anjali A Live, as mentioned here on the screen. So by using and by applying this code, you will be getting the discount in the total subscription amount, and rest of the details have been shown here on the screen. Okay. One more thing, like I'm gonna show you like what are the benefits you will get if you will be taking Iconic or the Plus subscription. So if you will take the Iconic subscription, the benefits you will get have been shown here on the screen. So even along with that, the notes are available on the learning app, which will be helping you to take your preparation to the next level, and all the other benefits have even been shown here. So whenever you will proceed further to take the subscription, you can use and apply the code that's Anjali A Live, as mentioned here on the screen, and by using and by applying this code, you will be getting the discount in the total subscription amount. This is regarding the Plus subscription. What are the benefits you will get if you will be taking the Plus subscription? All the benefits have been shown here on the screen, and you can use and apply the code that's Anjali A Live, as mentioned here on the screen, to get the discount in the total subscription amount. This is regarding the Lite subscription. This is going to be the slide where you can easily see the difference between the Plus, Iconic and the Lite subscription. Also, guys, the benefits you are getting in the particular subscription, depending on that, whichever you find more beneficial for you, you can take that subscription. Okay, so I hope each and everything is gonna be clear to everyone this way. But in case if you will have any question, query, or doubt, you can surely let me know about it then. Okay, also guys, here are some more important slides I would like to show you. This is regarding the subscription, Unacademy subscription or Unacademy learning app. This is regarding the session itself. This is something about me, and this is going to be about the community feature, as per which what are the benefits you will have of the community feature which is there in the app. Let me just tell you that quickly. So basically, guys, with the help of this community feature, you will get to know about the important updates. Okay, new updates, new courses, you can get to know about all these important details there. So this is how everything will be helping you. Now let's go ahead and let's start the discussion about the important questions which we will be covering in this session today. So let's start with the first one. It's going to be here, and this is going to be the question, the first question I'm going to take. Let's take it from the logic gates part, that what kind of questions you can expect, because that is the basic general topic we are going to have. So even that will be good if we will start sequence wise. Let's try to take the topics. So the first one I'm going to take is logic gate based question. While your logic gates can be present anywhere, but still, there is a different type of question we had in the previous years in CSR net exam. So I'm going to include that here right now. In the schematic figure given below, assume that the propagation delay of each logic gate is T gate. Now I'm going to show you how they have given the circuit diagram here, or all the gates, how they are connected. Okay, next, the propagation delay of the circuit will be maximum when the logic inputs A and B make the transition. Options are okay. Now, in this case, they have given in the schematic figure given below, assume that the propagation delay of each logic gate is what? That's going to be T gate, okay? Now, the next thing is, then what is the propagation delay actually? That's what you need to understand if you want to work on this type of question. So propagation delay means, if let's say you are having the output at this point 0, the NOT gate output, okay? In that case, you change the inputs, and then your output also gets changed there. For that or even other gates, the output gets changed. So in the process of changing those outputs, what will happen? We will be having the delay. Means if 0 was already present there and now that 0 is going to be 1, so there is going to be a kind of delay which we will have there, okay? And that delay is going to be our propagation delay, when it is going to change that value, right? So that's what they have provided you. They have given you the combination of inputs. Now let's read this statement too, and let's go ahead to solve it. The propagation delay of the circuit will be maximum when the logic inputs A and B make the transition from 0 1 to 1 1. What is this 0 1? 0 1 is the value for A and B. And what about this 1 1? It is also the value of A and B. Okay. But initially we are going to check for 0 1 and then for 1 1. So when we will do that, we just have to see how many outputs are changing. Okay. Maximum the delay can be there for 1 gate, 2 gate, 3 and 4. So 4 T gate. Why? Because each gate delay is T gate. So 4 times the T gate can be the maximum delay we can have here. So in that case, we just have to see for the given options, which one of the combinations is giving us the maximum delay. Is it 0 0 or 0 1? So if I will take 0 0 here, it's going to be 1, and then it gives us 1 and 0 for the OR gate. It's 1. This is plus 5 volts. We will treat it as 1. So 1 and 1 will be 1. 1 and 1 will be 1. At the same time, if I will consider the other second case, that is going to be 0 and 1. So A is 0, B is 1 there. So it will give you 0 now, and 0 and 0 will give you 0 now, and 0 and 1 will give you 0 now, and 0 and 0 will give you 0 now, right? So what is happening in this case? The output changed here, the output has changed here, the output has changed here, and the output has changed here. So what was the maximum delay possible? It was 4 times the T gate. And what is the delay here in this case? It is equal to 4 times the T gate, because everywhere the output has been changed. That means this can be your maximum delay possibility that is given in option D. Even if you will check with 1 1 0 1, or let's check for option A once just to make it clear, 0 1 to 1 1. Same way you can even check it out later on. So 0 1 to 1 1. Okay, firstly I'm going to check for 0 1. I'll take the different color here. Let's take blue. So 0 and 1, right? So it's going to give you 0 here, 0 0 will give you 0 here, 0 1 will give you what? 0 here, 0 0 will give you 0 here, right? Now, what is the next one along with 0 1? It is 1 1. So when I'm going to check the 1 1 possibility, what I will get, let's have a look at that part. Okay, 1 and 1. So it will give you 0 here, okay? But at the same time, it will give you 1 here, it will give you 1 1 1 here, it will give you 1 1, that's going to be 1. But this didn't change, so here is no delay in the first gate. Okay, so in that means that you are going to have 1 2 and 3 delays only, so 3T gate, right? This is how you can consider it, and you can simply get this question's answer. So what is the maximum delay possibility from the given options? It's option D. Even same way you can check out the other 3 options too, like the other remaining options too, and you will get to know like what's happening there. Let's go for the next question. If in case you will be having any doubt or difficulty anywhere, you can surely tell me about it. So your next question is, which of the following circuits implements the Boolean function that is function of A, B and C, that is equal to summation 1 2 4 and 6 question mark, and then it's going to be I0, I1, I2 and I3. These are the inputs, right? It is a 4x1 multiplexer actually. So now what we are doing, we are trying to include the important things here, and we are just trying to consider from the different sections what kind of questions we can expect. While a little bit modification can be there in the final expressions, the way they are asking the questions and all of that, but at least you are going to get to know that, okay, this is a possible case. This is also going to be something related to what you can expect in your upcoming exam, right? So we are mostly going to take the previous year questions in these analysis sessions. So even if you didn't check the previous sessions I had here for the analysis and the major portion which are going on right now, you can check them out for different subjects and they will surely be helping you. So for all the subjects, almost we are going to have these sessions, okay? Now I0, I1, I2, I3. This is going to be your S1 and this is going to be your S0. We can even denote it with A and B. This is also your 4x1 multiplexer, and the output we are going to consider here is going to be F, okay? Now, next one is going to be the C part. So what is there we will have for the C option, what kind of circuit they have shown or the block diagram they have shown. Let's just consider it. It is also going to be a 4x1 multiplexer. This is going to be C. This is going to be your 1 as a value given there, and then it is grounded, okay? See how they have given you the different options. So I0, I1, I2, I3, S1, S0, and this is going to be A and B. That's what you will have. This is 4x1 multiplexer. You are going to have, this is your F. So in this case, what will happen? again 0 for I0, I1, I2, I3, then C, S1, S0, A, B, 4 by 1 multiplexer. Okay, and next you are going to have is F. So what you have to do in this case, let's consider that part. It's going to be your which of the following circuits implements the Boolean function, which is F summation. Okay, so firstly you need to understand what they are trying to say and what they have given in the question. Are they talking about a particular function, how you will read it, and do you know what is the meaning of that symbol? If you know that, it's gonna be easy for you to go ahead to solve it, right? So in that case, that summation sign is gonna show you the SOP form, that is sum of product form. So if we are going to consider this as the sum of product form, how we can consider this part? How many variables are involved here? 3, A, B and C. So how I can write 1 as a 3 variable, 0, 0, 1, right? Then 2, 0, 1, 0. Then 4, 1, 0, 0. Then 6, 1, 1, 0, right? So I have written them in the binary number system. Now if I just want to write them in the sum of product form due to the summation sign given there, so how I will write it? It's going to be A bar, B bar, C plus A bar, B, C bar plus A, B bar, C bar plus A, B, C bar, right? Now, in this case, what will happen? See, you can observe one thing here in this expression, that the last 3 terms are going to have the complemented part in it, which is C bar, C bar, C bar. And just the first one is non-complemented. So we can directly consider this part that, okay, which of the following will have the 3 terms complemented and 1 non-complemented? That's option B. You can see it's a NOT gate connected here, and all 3 will be the I1, I2, I3 will have the complemented C given at the output. So that's why your answer will be option B. If you will even observe the next 2 options, they are not showing you the same phenomena and same thing there. Hence, these are not having the possibility to be the right answer, but option B will be the right one. One more thing, if there is somebody who doesn't know about the functioning of multiplexer, so I would like to tell you. Now, it is a 4 by 1 multiplexer they have given you, right? In this case, we are going to have 4 inputs and we are going to have the 2 selection lines and 1 output, right? Now, your output varies with the selection line values you select and you provide them. So basically, this is your I0, this is your I1, this is your I2, this is your I3. This is A, this is B, or selection lines S1, S0. So you can select AB as 0, 0. You can select AB as 0, 1. You can select AB as 1, 0. You can select AB as 1, 1. So these are all the possible combinations for A and B selection lines you can have, right? If you will see the 0, 0 in the decimal number system, so you can simply consider it will be equivalent to 0. 0, 1, it will be equivalent to 1. 1, 0, it will be equivalent to 2. It's 1, 1, it will be equivalent to 3. So that means if you will have the 0, 0 at A and B position, the input you will have at the first one, you can call it the I0, I1, whatever, but whatever is at the first position, that will come to the output part. Okay, so that means your multiplexer will show you the output as what? I0 there. At the same time, if we are going to talk about the next one, that is 0, 1. I'm taking the A and B values as 0, 1. So I'll get the second position input at the output side. And for I2, we will be getting the third position input at the output side. For I3, we will be getting the fourth position output input at the output side, right? So that's how it works. And even for any other case, because your inputs here will be dependent on the number of selection lines you will take. If you will have just one selection line, to the power 1 number of inputs will be there. 2 selection lines, to the power 2 number of inputs will be there. 3 selection lines, to the power 3 number of inputs will be there. 4 selection lines, to the power 4 number of inputs will be there. But its output always remains 1. I hope you got it. But in case there will be anything you are not going to get, you can surely tell me. And if everything is clear, we'll go ahead to work on more questions now. And these were the two different type of questions we have taken right now, and you can see how the way they are asking the question, or they can ask the question, can be different. It's not like you can just expect it to be just direct question from a topic, but it can be anything like we talked about it or we have considered it, right? Okay, let's go for the next one. If in case you will have something to consider and to ask related to this part, you can surely tell me. Let's go for the next important topic, which is related to operational amplifier. So then what you will be doing when you are going to consider the OPAMP, and what kind of questions they can ask you to consider in this part. Let's take one of the questions to make it clear. But at the same time, if you will be finding no, you are not getting something, or you are going to have any doubt, you will tell me about it and we can talk about that part. Let me just take a specific and a particular question here. Okay. Even there can be questions based on the filters, means it is high pass or it is low pass, or what kind of filter you can have corresponding to the given circuit. But at the same time, you can have the questions based on differentiator and integrator too. So I'm taking one question from that section, and then I will be sharing a trick which will help you to differentiate between the differentiator and integrator quickly and easily, and to even get your output. So it's going to be the input Vi in the following circuit is a square wave as shown in the following figure. This is R, this is negative, this is positive, this is output V. Okay, that's how you are going to have the information given about it. Next, we are going to have is which of the following, okay, which of the waveforms V naught best describes the output. I'll be showing you the outputs given in the options on the next slide. Here is going to be the first option they have given you. Second, okay. Third, if you will be getting, okay, this should be the answer, you can mention it in the comments that this is going to be the right answer. T by 2. and then this is T, and you are going to have the 0 0 here and V naught here and time T here. Okay, next one. Your option D says something like this. Okay, now let's go ahead. So actually in this case, what's going to happen? First of all, let's talk about the trick which will be helping you to identify whether it is a differentiator or it is integrator, okay? Depending on op-amp circuit. So first of all, if we will talk about this part, we are going to have the C and R combination present in the differentiator and integrator. But it depends on this part whether the capacitor will be present first or the resistance will be present first, and that will help you to decide whether your circuit is integrator or differentiator, because that change in their sequence will be changing the type of circuit you are going to have, right? Now for that there is a very simple and easy trick. You know, in the alphabetical order, C is closer to D. So when you are going to make the differentiator circuit, differentiator gives preference to C, means C will be present first. So this circuit is differentiator. While I and R in the alphabetical order will be like somewhere on a separate section or more closer to each other. So in integrator, the resistance will be present first. Means this capacitor will be replaced with resistance and the resistance will be replaced with capacitor. This is how you will easily be able to identify whether the given circuit is a capacitor or integrator or a differentiator. So this one is a differentiator, okay? Its input is a like the wave. You can see how it is given to you here. So when you will differentiate this kind of wave, so what you will get here? It will give you spikes or Dirac delta function, because it is going to be a square wave you are going to have. When you will differentiate the square wave, you will be getting something similar to this. It doesn't give you anything like this or this. Why? Because these are going to be for your sinusoidal functions, and this is not going to be there for the square wave. Again, square wave, when you will differentiate, cannot give you the square wave again, but it will give you spikes or the Dirac delta function. So after differentiating it, what is the possibility? That's what you have to select, and that's what you are going to get. Okay, I hope you are going to get it clearly, guys. If you are getting it, I'm going to take the next question here. So that is related to your flip-flop section. If in case there will be anybody having any kind of trouble in understanding anything we are talking about, you can surely try to let me know, while I can't see anybody's comment right now. So we are just gonna go ahead to do the next question discussion. Let me just write it here. Consider the following circuits consisting of an RS flip-flop. Okay guys, as I have told you, so right now I'm conducting the major portion series and the analysis series for almost all the subjects here on Unacademy Live CSR UGC Net. So if you're the one who wants to check out these analysis sessions and the major portion sessions to do the best preparation for your upcoming exam, you can check out these sessions which I have conducted till now, and there will be more frequent sessions we are going to have in the upcoming days and the time. So in that case, don't miss the sessions we will have here. If you're not going to attend any session live, you can even check out the recordings of the sessions, but that will surely be helping you if you are going to go through the session discussion I'm doing here. Okay, so you can even just have a look at them, whatever you missed, and you can get an idea about what kind of discussion is going on in these series and their sessions, so that you will be getting the great idea about what is important, what you need to prepare, on what section you need to focus more, and everything will be very much helpful for every one of you. This is the clock connected here. This is your J. This is your K input. And this is the 1. And this is the 2, right? So this is the circuit they have given us. Now next they have mentioned Which of the following connections will allow the entire circuit to act as a JK flip-flop? And the options they have given are connect Q to pin 1 and Q bar to pin 2. Okay, and the next one is given as connect Q to pin 2 and Q bar to pin 1. And the next one is connect Q to K input and Q bar to J input. The last one says connect Q to J input and Q bar to K input. Okay, that's what they have mentioned. Now the point is what we need to know to solve this question. So actually guys, if you have prepared flip-flop, if you have not prepared, you should. But if you have prepared it already, and if you have not prepared for both of them, I'm going to answer right now. So once you get to know about the circuits, that how the JK flip-flop is going to be there, how the RS flip-flop is going to be there, okay? So you will get to know that what they're asking you. Consider the following circuit consisting of an RS flip-flop and two AND gates. So this is your RS flip-flop circuit and the AND gates have been connected separately, right? So if you want to convert it into the JK flip-flop, then what you have to change? So if you will see the circuit, this should be connected to this side, like pin 2. Here they are providing the input instead of this, but in the main circuit it happens this way, okay? So that means we are saying Q to be connected to pin 2 and Q bar should be connected to pin 1. Hence, if you are familiar with the actual circuit of JK and RS flip-flop, you will be familiar with that part and you can simply say, okay, it is the option B, which is the correct option. And that's how you can simply do it. Now, I hope you're gonna get that it just requires you to have the information about the circuits and that's it, you can get the answer. Let me know if there is any question, query or doubt you will have. We can surely talk about it, but if everything is clear, then that's great. So we are going to keep it this much right now, guys. And thank you so much, everyone, for joining the session and for attending it till the end. As I've told you about this latest offer initially in the session, so if you're the one who wants to start the preparation under the guidance of top educators and you don't want to miss these important like courses, classes, and the notes by the top educators, in that case, you can take the subscription and use and apply the referral code that's Anjali A Live as mentioned here on the screen to get the discount in the total subscription amount. One more thing, guys, the offer is just valid till 14th April. So if you don't want to miss it, you can take the subscription now, or even you can share the information with your friends to let them know about the offer along with the code, because they will be able to get the discount or grab the offer after using and after applying the code that is Anjali A Live. Now, next thing, what are the benefits you will get if you will take the iconic subscription has been shown here. What are the benefits you will get if you will take the plus subscription have been shown here. And I hope that this is about the light and the difference between the plus and iconic subscription. You can clearly have a look at that part from this slide. Now, I hope each and everything will be clear to all of you guys, but in case if there is anybody having any doubt, you can surely tell me about that too. We are going to keep it this much right now. Thank you so much, everyone, for joining this session and for attending it.